Okay, Mo. Listen. Next one, IUPAC naming. So definitely 2 marks you can expect for naming compounds. It may be IUPAC or common name, right? But here, first I have written the difference between iso, secondary, tertiary. The difference you can see here in first page. See this iso. What is called when we have to use the term iso? Two methyl groups bonded to the same carbon. Listen first. Don't get any confused mark. Actually, this will be very useful not only for writing the formula or name. Sometimes for chemical reactions you will be given with only name, maximum common name. That time you need to know the structure of the compounds, right? So two methyl group bonded with same carbon, that is iso. Iso to total number of carbon 3, so isopropyl. Here two methyl groups bonded with same carbon, iso. Total number of carbon 4, isobut or isobutyl. This one is iso to 5 carbon, 5 carbon. And see, now the carbon which is directly bonded with functional group, that is alpha carbon. When alpha carbon directly bonded with 2 carbon, then that carbon is said to be so that one is called secondary. Here is a special case for 3 carbon, iso and secondary propyl both are same one. But now see, in the next case, functional group alpha carbon. That alpha carbon bonded with 2 carbon atom. Here 2 methyl groups not bonded with same carbon. This methyl bonded to CH, this methyl is bonded to CH2. So I cannot consider iso. This is secondary. Secondary to number of carbon 4, secondary butyl. Secondary to 5 carbon, secondary pentyl. And similarly, alpha carbon bonded with 3, that is tertiary butyl, tertiary pentyl. And now 5 carbon in this way connected, that is called neopentyl. This structure is called as neopentyl, right? So these are the things you must know for the difference between iso, secondary, tertiary and neo. Just take down this.
హలో ఉంటానగా Pitching it.
Next one. Vinyl. CH2. Hey, Gowdy. CH2 double bond CH. Right? Actually, CH2 double bond CH2 is ethane. In ethane, when you remove one hydrogen, it's called vinyl. CH2 double bond CH. In that vinyl, when you add halide, it's called vinyl halide. When you introduce alcohol, vinyl alcohol. When you extend that vinyl to one more carbon with a 3 carbon atom, then it will be called as allyl. So allyl halide, allyl alcohol. And next one is, this is the example questions in your textbook. See, this is the structure they have given, right? For writing the IUPAC name, first to find out the linear chain. CH3, single bond C, with that one hydrogen, double bond CH, CH3, Br. But I am very convenient with the linear chain, so I am bringing the Br at the bottom and I am making the chain straight. Now 1, 2, 3, 4, 5 carbon. It's a pent. Double bond is that ene. When I label that, I should give the priority for double bond first, according to the IUPAC rules. So 1, 2 and 3. Double bond is placed between second and third carbon. In second and third, 2 is the minimum number. So pent 2-ene is a parent compound. Then where the bromine is located? 3, 4, fourth carbon. So 4 bromo pent 2-ene is the name of this compound. Take down this. Next one, which of the following is faster towards SN1 reaction, SN2 reaction? Questions may come, right? The order of the SN1, SN2. Here SN1 is tertiary, then secondary, primary. Suppose if they are asking increasing order, you should start from primary, secondary, tertiary. This is decreasing order, right? So increasing order, decreasing order. What order they are asking, based on that you should type. See, this is the structure what they have given for the compounds. Compound 1, compound 2, only bond line. Right? I have mentioned the carbon atom on the bond line. Now, this is chlorine, functional group. So this carbon, alpha carbon, directly bonded with one carbon. It is a primary. Alpha means the carbon which is bonded with the functional group. Now here, this chlorine is a functional group. This carbon is alpha carbon, directly bonded to two carbon atom, secondary. So comparing primary and secondary is more reactive. Therefore, compound 2 is more reactive towards SN1. The same way for SN2, primary, reverse order. When you want to write in the increasing order, tertiary, secondary, primary. The same compound only I have taken. So compound 1 is faster than compound 2. Next one, arrange the following compounds in the increasing order of the property given. So in this chapter, the property is boiling point. Arrange the following compounds in the increasing order of the property given. The property is boiling point. So 2 carbon with bromine, 5 carbon with bromine. Listen now. 1 carbon with bromine, 4 carbon with bromine. The key point is when carbon chain increases, when carbon chain increases, boiling point increases. Right? So here 1 carbon, 2 carbon, 4 carbon, 5 carbon. So which one has a higher boiling point? 5 carbon. So 5 carbon given in option 2. So increasing order only always asked, right? So 1 carbon is third one and 2 carbon is first one. Then 4 carbon is fourth one. 5 carbon is second one. So increasing order. Is it clear? And moreover, a reasoning question also there. From this, any 2 compounds, first say third and fourth you may be given, and they itself gave the compound fourth one has higher boiling point. They will ask the reason why. The reason is when carbon chain increases, boiling point increases. First point. Second point, when carbon chain increases, surface area increases. and van der Waals force also increases. Right? Surface area increases, van der Waals force also increases. These two are the reason why boiling point increases. And the next one, next example. Now what and all we discussed with iso secondary. The compounds only they mention N-butyl bromide, isobutyl bromide, secondary butyl bromide and tertiary butyl bromide. So all are butyl bromide. Listen. N-butyl, which means see 1, 2, 3, 4. 4 carbon connected in linear chain. So N-butyl bromide. Isobutyl. Actually iso structure 2 methyl group. Iso 2 4 carbon. With that bromine. Isobutyl bromide. Then secondary butyl. So functional group Br, alpha carbon, which is bonded with 2 carbon atom. That is butyl. So one more carbon added. So secondary butyl bromide. Tertiary butyl. This is the tertiary structure. Tertiary butyl bromide. Now, when branches increases, boiling point decreases because surface area decreases. Van der Waals force of attraction also decreases, right? So tertiary will have the least boiling point, highly unstable. Then N-butyl, which has the longest chain, so that which has higher boiling point. Now you may get a confusion. Compound 2 and 3 both have branches, right? Now in compound 3, this methyl group very closer to bromine. So hindrance is very high. Hindrance is very high, which means less stable. Highly unstable. Highly unstable means which has low boiling point. Right? So third one, then second one, then first one. This is the order. And last page. Alkyl groups are similar. All are methyl group only. Now we changed only halogen bonded. Fluorine, chlorine, bromine, iodine. When you go down the group, atomic weight increases. When atomic weight increases, boiling point also increases. Right? So mass increases, boiling point increases. So as it is the increasing order. And see why long chain compounds have high boiling point. Surface area increases, van der Waals force of attraction also increases. Is it clear? So that's all about this chapter. And see, in this chapter we have missed only IUPAC naming I covered, named reaction I have covered, and then arrange the following in the increasing order: SN1, SN2, and boiling point. That property also we have discussed. And moreover, distinguish type of questions in this chapter not there. So we need not worry about that. And the other one is conversions. So if you make thorough conversions, this chapter also works.